All right, so this is our activity one circuit in simulation in multisim. So you see the resistor and capacitor, they are using the same value as being measured. And here, this is our pulse voltage. Um, the period is 20 microsecond with each square, each peak duration about 10 microseconds. We choose this to because we want to make sure these numbers are large enough, larger than our uh, like larger than 5 time constants for our circuits. So now let's do the simulation part. We want to visualize how the voltage across the capacitor changes after we switch on or switch off using this source voltage. So to do this, we need to go to the simulation setting because we want to do transient analysis uh, since our since the voltage across the capacitance is not constant, it's not steady, it's a vary respect to the time. So we have to use transient analysis. Um, so first we set the length of our simulation to be about 50 microseconds. So it's about 2 period uh, for the source voltage. And we want to visualize the first one is the voltage across capacitor, which is the voltage measured by this probe. And second, V2. V2 is the node voltage here. Uh, if we look at corresponding to the ground terminal, it means V2 is the source voltage we have. So we want to visualize our uh, capacitor voltage uh, against our source voltage. So now let's run the simulation. So now you can see we have two curves. To visualize, the red one is our voltage across capacitor, and the green one is our source voltage. So the green one is a square wave, and we see the red one is following the exponential increasing and decreasing curve we just talked about in our lecture. So now what we need to do, we want to measure the time it needs to charge, to fully charge and discharge. So when it's increasing, it's charging. When it's decreasing, it's discharging. So to do this, we need to use cursor, just like we did in oscilloscope. So we want to show cursor, and you see there's one and two cursors. So we want to put our let's see, um, we want to put our first cursor, the blue one, at the beginning of our. Let's measure the discharging time first. So first we need to move the first cursor at the beginning of our discharging process, and the second cursor at at the point where we think the the capacitor is fully discharged. So I guess it um, should be around this point. Yeah. So now the time interval between these two cursors is the time we assume the capacitor it takes to fully discharge. So to get that value, we need to look at this small panel here. Um, so if you look at here, the distance between these two cursors uh, is should be dx here, which is about 5.6 micro. So the unit is second. Uh, so the time it takes to fully discharge from the simulation is about 5.6, 5.64 or 5.65 microseconds. And then we measure the time needed for fully charged. Um, Again, we move the, oh, okay. So again, we move the first cursor to the starting point of our charging process. And the second cursor, oh, no. And the second cursor, yeah, second cursor to the point we think is almost fully discharged, and the first cursor to the point to the starting point of charging process. Okay, so now we see the time interval between two cursors is about 5.1 or 5.10 microsecond. So this is the time we have from our simulation for the discharging process.